When you stare at the night sky for a long time, you eventually start to notice patterns. Some are simple, others are deceptive, and still others are so precise they force you to reconsider your own understanding of the cosmos. When the first data on 3I Atlas's trajectory appeared on my screen, I didn't immediately grasp what was unusual about it. Over decades of work, I've seen orbital paths of all kinds of objects: comets with enormous periods, interstellar wanderers, bodies on hyperbolic trajectories. But as the map filled with new data points, it became increasingly clear. There was something deliberate here, not in a fantastical, but in a mathematical sense. 3I Atlas's path was noticeably different from the behavior of ordinary interstellar debris. It didn't just fly by like Oumuamua, and it didn't dive deep into the system like 2I Borisov. Instead, its trajectory formed a clean, neatly calculated arc, leading precisely to a specific region of space, the area where Jupiter's influence begins to surpass that of the Sun. This is not the planet's immediate vicinity or a section of its orbit, but rather the precise point at a distance where the gravitational balance shifts from the Sun to the gas giant. For an astronomer, this is not an abstraction. Such parameters are not achieved by a random comet drifting for millions of years among the stars. When I first spoke about this, many wrote to me saying it was all a coincidence. Coincidences certainly happen, but repeating structures deserve attention. Precision is also information, and when an interstellar object demonstrates such precision, it is wrong to ignore it. To understand why this is important, one must remember every gravitational system has transition zones where the influence shifts from one massive body to another. For Jupiter, this sphere is calculated with high accuracy, and the fact that 3I Atlas is moving directly towards it is, in itself, already uncharacteristic. But what alarmed me even more was the incredible subtlety of calculation required to hit this region. To reach the specified radius, the object would have had to fly at a specific angle, at a specific velocity, and maintain this course for millions of years without deviating due to the interstellar medium. Astronomers are accustomed to considering such visitors from other systems as chaotically ejected, the results of collisions, gravitational slingshots, planetary formation processes. These are disorderly ejecta, and they extremely rarely enter another system with such filigree precision. From a scientific standpoint, this is a low-probability event. Not impossible, but so unlikely that it deserves study. It is precisely such cases that push science forward. At a recent briefing, NASA confidently stated that 3I Atlas is an ordinary comet. I have no issue with confidence when it is based on a complete set of data. But confidence that ignores anomalies is not scientific caution. It is the absence of it. In the very images presented, one can clearly see something resembling a narrow, elongated structure pointing forward in the direction of motion. That is, not away from the Sun. In natural comets, gas jets are always oriented roughly in the opposite direction due to the evaporation of ices heated by sunlight. 3I Atlas demonstrates a completely different configuration. This is not proof of an artificial origin, but it is an indicator of an unknown mechanism, and any unknown phenomenon deserves investigation. I merely proposed a hypothetical possibility. Such a structure could work as a system for clearing the route of microparticles. Whether natural or not, we do not yet know. But to dismiss the very fact of observation simply because it is inconvenient for established models is the wrong approach. That is why I repeatedly emphasize the need for conclusions based on data, not on authority. I am often asked, if 3I Atlas is so important, why isn't it heading for Earth? The answer is simple. Earth is not the primary gravitational landmark. That role is played by Jupiter, the most massive planet, the main regulator of comet flows, and the shaper of long-lived orbits. In every system we know, the largest planet defines its architecture. If an interstellar object aimed to study a system, investigate gravitational gradients, deposit material, or simply pass through a zone of stability, Jupiter's influence would be key. And there is no claim of intent here, only physics. When 3I Atlas crosses this region, it could, at least theoretically, release fragments, slightly adjust its own path, interact with local perturbations, or alter its future interstellar trajectory. Whether it is natural or not, this specific point in space is of particular interest. After its perihelion passage, another strange behavior was detected: non-gravitational acceleration. It was also observed with Oumuamua, which led me to propose the idea of solar radiation pressure and the object's possible thin geometry. In 3I Atlas, the effect is weaker, but it is present, and it is deflecting the comet exactly in the direction that brings it precisely into Jupiter's sphere of influence. Not approximately, but with extreme precision. This leaves three possible explanations: incredibly fortunate natural outgassing, directed mass loss of an unusual nature, or some kind of passive or active correction mechanism. I am not asserting the third option. I am merely saying that science's task is to consider all hypotheses until data rules them out. Our civilization has existed for a negligible time on cosmic scales, and 3I Atlas began its journey billions of years ago, long before the appearance of humans, mammals, or even dinosaurs. We are not talking about a meeting of civilizations, but about dynamics inscribed in the history of the universe. And the question here is not whether the comet is artificial or not, but that we finally have the tools to study such phenomena not as rare curiosities, but as full-fledged scientific events. We can detect faint deviations, combine global observation networks, revise theories, and demonstrate the very humility necessary to learn from nature. The universe does not send us messages, but it gives us events from which we can extract knowledge, if we do not look away. The fact that 3I Atlas is heading precisely to Jupiter's sphere of influence demonstrates elongated structures along its direction of motion, and slightly deviates from calculations is a reminder. Look closer. The next object might come closer, the next one might be clearer, the next one might bring undeniable evidence. We are witnessing the birth of a new field of science, interstellar archaeology. And just as on Earth the first discoveries begin with anomalies, this is precisely why it is important that 3I Atlas is moving towards the Jovian zone more accurately than it should under random conditions. Because precision also carries meaning, even if unintentional. Because deviations are not noise, but a chance to see more. Because science must listen to inconvenient data first and foremost. And because in such an ancient and vast galaxy, an object that began its journey long before us is still capable of telling us about worlds that existed before us and about those that may exist after. For now, we must observe, record, analyze, and retain enough wisdom to remember. The universe is always several steps ahead.